Hello everybody, I'm SocietySucks, and today I'm checking out a video called The Simple Secret to Runway Numbers by CGP Grey. I think this video is a re-upload, because I know there was a video like this before on his channel, but it was pretty old. And now it's popped up again, and it's only 2 days old, so I think he re-uploaded the video for whatever reason. Maybe he got something wrong originally. I'll assume he explains why he decided to re-upload the video, and if not, then I guess I'll just never know. So let's check it out.
While waiting on a plane during taxi till takeoff, looking out the window, you may have noticed the giant number numbering the runway, say 8, which implies 7
I've
others
never flown
exist,
a plane before.
at least, but this is a flight out of LOL Airport in Nevada's Desert of Nothing. There's only 2
LOL?
runways, which, given the passenger load, seems like maybe 1 too many already. What's the deal with runway numbers, you might wonder aloud? Oh, hello again. Flying to Nook as well, are you? It is a long flight, so there's tons of time for me to tell you all about runways. Let's begin. So, before you can number a runway at an airport, you need to build the airport. And before you can build the airport, you need to plan the port. And what needs figuring first is which way to run the way. Pilots want runways with winds in parallel for physics reasons that we are going to skip, both because lift physics is something people really like to argue about, and this isn't a physics video. Yeah, I'm recording a runway video right now, hope you don't mind. But the summary is planes take off and land into the wind because it lets them use less runway and makes for safer and stabler landings in particular. Now, planes can land with winds unaligned, but it's unsettling to watch these crosswind attempts as pilots do their best to face into the wind while landing on a runway that does not. Oof. So airports too want winds running with the runway, but the universe is indifferent to human desires. Wind winds as it wants, so the simple solution in aviation early days was to build a triangle of runways, put up a little windsock, and direct the pilot to the runway that paralleled the sock and thus the wind. But as aviation grew, so did airplanes, and thus their runways, making the triangle trick impractical for big urban internationals. But the simple sock still solved it. See, if you record when and which
I always wondered what that thing was for. Now I finally know.
Which way the windsock blows and with what wind force, you've grown yourself a windrose, a clever little data viz tool with the sock in the center of compass points for orientation and bars colored and sized for strength and frequency of wind. Though it reads opposite actually of everyone's expectations, with the lines showing the way the wind blows from and not to. Physics stuff just loves to opposite actually. Let's just agree to avoid physics for this video, shall we? Windroses.
I would definitely make the mistake of assuming it's the other way around and mess something up.
Reverse readings aside, they reveal that in most places, most of the time, most of the wind mostly blows back and forth in one direction. So that's surprisingly convenient. Thanks, indifferent universe. Oh, you did it for other reasons? Well, still, this convenient wind happens because wind is a current of air, transporting heat from where there's more to where there's less. The Earth is blasted by the nuclear heat of the sun, with the equator getting hit hot hardest, making hot air rise there as it cools out along the edge of space before coming back down, creating a big scale
this is related to the actual numbers, but
pattern all up and down. And because the Earth
I'm
is
sure
a
he'll
sphere
explain
that
it
spins,
soon.
those cylindric convection currents of air on the surface twist clockwise north of the equator and counter below. This is the Coriolis effect, creating coiled currents of air everywhere, which is cool, but also physics trying to sneak back into the video, and this isn't a physics video. All that matters is this creates the pretty stable pattern of trade winds, and if you're planning a port, you need only know which way does the wind mostly blow. Though at some locations, the windrose reveals 2 frequent directions of wind, so if you want to constantly and safely keep open the airport, you're going to need to run a second way. This is why many airports have an X or V layout like LOL. They're not necessarily doing double the traffic of a one-runway port, but rather have double the chance of crosswinds when the tower will need to reroute pilots toward the other alignment for safer landings. And once you have 2 of something, you need names or numbers. Sure, you could just go with run 1 and run 2, but pro tip, try never to use the very first thing that comes to mind without giving it a bit of a good solution. First. And the windrose reveals a better way with the compass points, which form a circle of 360 degrees, starting at 0 north, east 90, south 180, west 270, and back to north makes it 360 as well. These
the numbers are based
come from
on
ships of the seas, because captains and
how many degrees it is.
Vast, featureless nothing could still count on their compass to point toward the North Pole, assuming no iron hooks happen nearby, and with north as a fixed navigational point, could then communicate their heading with names broadly, east, south, east, or numbers precisely, helm to 108. Quite handy. So it's no surprise these compass those headings got passed from sea ships to airships. Thus, on the Windrose devised plans for any airport, the runway is already aligned with navigational numbers begging to be used. But before grabbing the obvious one, again, ponder for a moment. The runway points from the perspective of the port toward the plane. The rather more important heading to use is
so
from
which
the
one would you
plane's
use?
perspective approaching the port, which on the plan is at the opposite end actually, because it's what number matches the compass in the cockpit that's critical. Alright, this needs a couple of example airports. Take one with a north-south runway. When the wind blows from the north to the south, the tower directs pilots to approach from the south, meaning they need to point the plane north, which on their compass is a heading of 360 degrees. So let's put a big 360 on that end.
Zero.
When the winds reverse, the tower directs pilots to approach from the north, to fly south, which reads 180, so let's put a big 180 on that end as well. Now that we've got our heading numbers, the convention is
that
to
would be
round
confusing.
them to 10 and cut off the 0 for the runway number, because we don't need 3 sig figs of precision when airports have single-digit numbers of runways, and the very stressed air traffic controllers in the tower need to repeat precisely these numbers hundreds of times a day, so saving syllables here really matters. Thus, when the tower tells the plane to use runway 36, the pilot knows they need to get south of the airport to land facing north, and while there are like a million indicators in a cockpit, the pilot can always confirm they're doing it right by reading 360 on their ancient ancestors' compass. This low-tech check is useful as a fallback because a compass can see the
Just
way
in case.
even when eyes and other equipment cannot. As a 2-runway example, an airport with a perfect ordinal X would get numbered thusly. Northwest to southeast gives 315 for one end, because that's the way the pilot needs to point, and 135 at the other. Round to 10 for 320 and 140, then drop the zeros to get runways
So they just
32
rounded
and
up to the
14.
nearest.
On the other side, 225 and 45, round to 10 again, drop the zeros for 23 and 5. Now, when the towers talk to the pilots, they say each digit individually, so runway 23, because clarity here is critical, which is also why the font and exact size of these digits is standardized worldwide. Though there are disagreements between the abundant aviation agencies as to if single-digit runways like 6 should have a leading 0 for clarity, or if that leading 0 should only be in our hearts, which it shouldn't be. Anyway, that's the surprisingly good system behind numbering these numbers, which is always a delight to discover, unlike some other.
I feel like they should add the 0, because, I mean, you would probably expect 2 numbers on most things, so if there's only 1, it might be a bit confusing. So I would just add the 0.
Other numbers I could mention, though there are a couple of wrinkles. For think about it, if the wind mostly blows back and forth in most places, then most big, busy urban international airports will need multiple runways in parallel. But parallel runways have the same heading, thus the same number under this system.
How do they deal with that?
Unclear for pilots to say the least.
Number 6 on runway 1, I guess? How else would you do this? Maybe add a third number, so it's 031, 032, and so on.
So all the agencies assembled to agree. If you have 2 parallel runways, they will have the same number, but add an L or an R for left and right.
What if you have more than 2?
To construct a third runway, add a C for center 2. But with 4 or more, 2 runways will get the correct heading number with L and R, but the others, they're going to get the next closest numbers, but not exactly correct numbers, which is practical, I suppose, but also, it's all slightly misaligned. It's big airports. Like, it doesn't line up. Like, just try not to think about it, okay? Just try not to think about it. Oh, we're landing at Nook already? Wow, flights fly fast when you're flapping about flying. Time to put this knowledge to use. Our compass heading reads 42 degrees, so round to 10 for 40, cut the 0, and we'll be landing on runway 04. And since there's only 1 runway at Nook, it'll be perfectly aligned.
Well, it's just 04
No
then.
doubt about that. Oh, it's 5, not 4.
How? Why?
Embarrassing. I guess I need to delete this video now. Hey, why are you painting a new runway number? You do that every few decades? That must mean...
Why? What?
Runway numbers depend on where the North Pole is. And so, watch out! There's a geography video inside this video called
God.
Where is the North Pole Really? Okay, to find the North Pole, remember that the Earth is a sphere that spins. Oh, sorry, we already went over that. We draw a line about which this spin occurs and name each end the North and South Pole. Starting with these poles, we clever humans created a square-ish coordinate system for our spherical Earth, the detailed creation of which I'm going to skip because that's a physics story for a never time that took hundreds of years and needed lots of clocks, and to make it official that London rules and Paris drools. But anyway, this grid is what every modern navigational system uses to get around with the GPS, global positioning, coordinates it gives. But if you were to use your GPS to direct you to the North Pole so that you could experience the planet rotating you in place as the stars circled overhead and you pondered the scale of the indifferent universe and your tiny existence
and just how
within
insignificant
it, if you took out
you
your
are
compass to double check that the GPS got the spot right, the compass points you over the horizon toward another North Pole. What gives, compass? Well, what did you expect? A compass is a magnet, and magnets follow magnetic fields. That's like their only thing? It's not a math magnet. Your magnet compass will take you to the gigantic magnetic field spewing forth from inside the Earth. So there are two North Poles, one for math and one for magnets. I mean, I guess if you want to be technical about it, there are three North Poles because the magnetic field the North Pole of a magnet points to is the South Pole of the Earth's magnetic field because opposites attract. But look, we're just going to ignore that because this isn't a physics video and there's been enough it's the opposite actually already.
You sure
and
it's not a physics video? There's been a lot of that.
Norths, but we're moving on. There are two norths, math and magnets. The compass points to the magnetic north and the GPS points to the geographic north. They don't have anything to do with each other, but for navigation humans have used both. One isn't better than the other, though math/geographic north is now often called true north, which feels a bit like humans picking the new one as their favorite one. Oh, and ships of the seas have stopped using the old magnetic north and now navigate with GPS using the true north, even modern pirates, but planes and pilots still love the traditional magnet north. And we can stop thinking about this because they're pretty close anyway. Although, isn't that kind of weird just how...
Well, they are pretty close. However, I feel like even the slightest difference could cause some mistakes. Something unfortunate to happen if you get it wrong for whatever reason, if you confuse the two.
How close the unrelated poles are on a planetary scale. Earth just so happens to have a giant magnet that sort of, but not quite lines up with the planet's top and bottom. In different universe, are these things secretly related? And still, why would runway numbers change just because they're pointing at the magnet one, but not the math one? Oh no, there really is an unavoidable physics video inside this geography video.
Oh my God.
And it's called Magnets. What's your deal? Okay, we really can't cover everything about magnets because it's just
that would take
so
way
much,
too long.
But some bits of some metals, such as iron,
and most people probably wouldn't even understand it because they never covered these kinds of physics.
generate around them a magnetic field. Why and how were a mystery for a long time until we discovered that if you take a wire and run a current of electrons through it, aka electricity, this current also generates a magnetic field around the wire. But weirder, if you start with a current of electrons and pop them in a magnetic field, the current will curve. And oh look, you've stumbled upon a clue to one of the fundamental secrets of the universe. Magnets and electricity are two expressions of the same thing, electromagnetism. That's why in science class you can coil up a wire, send a current of electricity through it, and the whole thing becomes a magnet. One you can make stronger and stronger.
We've never done stuff like this in school.
Because curving currents are
which is a
magnets,
shame.
Which is why when you cut the current, everything drops. Our just iron magnets are doing the same thing, but you need to zoom down and down and down.
Because
and down
something like that would have been far more interesting than just
here, an atom of
listening
iron
to
has
a teacher yapping for 45 minutes about that.
Whirl around, they create a tiny current and a tiny magnetic field. Zooming even closer, each electron spins, and this spin acts like the universe's teeniest, tiniest current, creating the teeniest, tiniest electromagnet. Okay, look, whirl around and spin don't mean what you think down here, because in the land of quantum, words mean nothing. There is only math that we're not gonna do.
Just math.
Just go with it. Anyway,
Nothing
in most
else.
atoms, all these current-created tiny magnetic fields arrange themselves against themselves, so it all cancels out to nothing. But in a rare few atoms like iron does there happen to be an imbalance that aligns and adds up, and thus each iron atom is a tiny magnet. And if adjacent atoms align, their little magnetic fields add up. And zooming out and out and out, if all the atoms in the iron are aligned, then the iron acts as one big monkey-sized magnet, but deep down inside, it's just electron-sized electromagnets. And scaling up and up and up and up to the whole Earth's magnetic field, it's an electromagnet all over again. See, the Earth is made of parts: the thin, perilous, cool crust on which we live, the inner solid core that is several thousands of degrees hot, a middle mantle mostly solid and relatively cool, and critically, a ring of metal liquefied by the hot core. And just as on the surface do hot spots cause convection currents of air to try to even the energy out, so too does the unbelievably hot inner core cause convection currents of liquid metal. Metal that happens to be mostly iron, our magnetic
It's crazy how all of this goes into a video about runway numbers.
friend. Thus, as this mixture circles, so do
You would think
all
none
its
of this would be
electrons,
even
curving
related to
currents,
each other.
Which gets us magnetic fields, baby.
But apparently
Though,
it
as
is.
individual coils, it's not very strong to start. To get a planet-sized field, you need to somehow stack the coils, which is where the Coriolis effect comes back in. For just as Earth's spin causes convection currents of air into coils, so too does Earth's spin cause convection currents of liquid metal to coil, making the fields stronger, turning the whole of the Earth into a giant electromagnet. Wow. If there's one thing the indifferent universe loves, it's
Can we go
repeating the
back to
same
numbers
patterns
on
across
runways?
scales and domains. Such austere efficiency. It's beautiful. Oh, get back to the runways? Oh, unlike a real
Exactly.
electromagnet made of stable metal, all that swirling liquid iron inside Earth is not stable. So at any moment, the field can split into multiple magnetic poles, roam randomly, or diminish entirely before, oh my, flipping north to south and south to north, which it does every couple 100,000 years or so. And we have no way of predicting when. Great. That'll cause some trouble.
Fantastic.
And there's a clue that it's coming because the strength of Earth's magnetic field has dropped 10% over the last couple 100 years, which is concerning. So,
Yeah, I heard about that. Apparently something is supposed to switch from south to north. I think maybe it was this, or maybe it was something else. I don't know. But yeah, this is terrifying because if this is the first time this is going to happen, how is everything going to be affected? Think about it. How is technology going to be affected? Everything else? Well, maybe it won't happen during our lives, so we don't have to worry about it. Let the next generation deal with it. And the fallout
if you're
it
watching
causes.
this video after the flip, 1, take everything I said about magnetic north and magnetic south, and now it's the opposite, actually. And 2, if it's been a couple 100,000 years since my last upload, don't worry. That's about normal.
YouTube won't be
so
around that
be
long.
sure to smash that subscribe button so you don't miss the next video. No, and hit the bell. God, I hate that you have to do that now. Alright, time to wrap this up. First, this giant electromagnet made of liquid metal, Coriolis convecting inside Earth only semi-stably means Earth's magnetic field moves. That finishes with the physics and means the magnet North Pole moves, and quite a lot on human timescales. When we started measuring, it was safely inside of Canada, but it's recently rocketed north. Geography over, so we can finally get back to the start. Since runway numbers are
Get back to
derived
the
from
runway
the heading
numbers.
on a compass, when the magnet north moves, the runway numbers need to change to match. And the closer your airport
So they're always
is to
changing.
a magnet pole, the bigger a difference its movement makes, and thus the more frequently you need to update the number. Which is why it's no surprise that Canada, with more northern runways than anyone, was the first to get pretty tired of frequently repainting all her northern runways, and so changed her system to be based on the unmoving math north instead. But this means when flying over her territories, pilots can't count on their compass to match the runways and the winds. They can't
So if electronics fail, they're screwed.
use their GPS, assuming the battery is charged,
maybe
but
not
these
screwed,
runway
but
numbers
it's
are
gonna make their job more
inconsistent
difficult.
with runways in the whole rest of the world. Now, Canada thinks her system is better and has created an aviation agency to try to convince all her international friends with airports more equatorial and thus less of this problem to try and switch with her from the old and busted magnetic north to the new true north. If pirates can do it, why not planes too? Yar! Well, because it's mostly a problem for you, and thus there's not one system for numbering runways, but 2.
No, but only one country uses the second one, so what does it matter? Most still use the magnetic
Hey
north.
you, if it's your second watch through, did you notice this video is a version 2? With sharp eyes, you might have spotted what's changed. During the landing at Nook,
I've never
V1
watched
had
the
runway
original.
number repainting go up a number when it should have gone down, the opposite.
That's
actually.
it?
Now, after first upload, this seemed like only a glitch, right? Causing some confused comments to come.
So the whole reason for the re-upload was because it went up a number instead of down. That one moment in the video that most people probably didn't pay that much attention to is why he re-uploaded the whole thing. That is ridiculous, but it shows that he cares about being accurate. So props to Gray. Good job, even if mostly pointless. So yeah, the runway numbers constantly change because the magnetic north constantly changes. Except for Canada, who just uses GPS now. And there's a lot of geography and physics that goes into this, which is something I did not expect at all. And yeah, I think I've said everything I wanted to during the video, so I hope you enjoyed. If you did, consider subscribing and leaving a like. If you're interested, why not watch this video right here? And with that, I hope I'll see you in the next video.